we will now discuss 4 questions. Question numbers 61, 62, 63 and 65 from the section Linear Algebra that have appeared in the TS Set 2023 October examination. And this video is suitable for GLDL, JL, Junior Lecturer, DL, Degree Lecturer examinations and AP Set and CSIR Net examinations also. And some of the inputs were taken from Sripad Venkatesh of CVR College of Engineering. Now, let's go to the first question. The first question, question number 61 with this question ID. The question is, A is a square matrix of order 4 whose eigenvalues are 0, 2, 4, 6. Using this information, which of the following cannot be found? We are given 4 options. Option 1, rank of A. Option 2, determinant of A transpose A. Option 3, eigenvalues of A plus I inverse. And option 4, the eigenvalues of A transpose A. So, we are given a 4 by 4 square matrix capital A with its eigenvalues 0, 2, 4, 6. Using this information, which of these following 4 options cannot be found? Let's now discuss the solution of the problem in detail. Given A is a square matrix of order 4 and 0, 2, 4, 6 are its eigenvalues. Let's go for the option 1. A has these 4 eigenvalues. These are all distinct. So A has distinct eigenvalues. When A has distinct eigenvalues, then the matrix A is diagonalizable. And the matrix A is equivalent to a diagonal matrix whose diagonal entries are 0, 2, 4, 6. So, A is similar to or equivalent to a diagonal matrix. This is the diagonal matrix whose diagonal entries are 0, 2, 4, 6. Agreed. Then, can I find the rank of A? Yes. The rank of A is equal to the rank of D. Why? Because A is similar to D. Similar matrices have the same determinant, same rank and determinant. The rank of A is equal to the rank of D. And look at this D. D is in the echelon form. Therefore, the rank of D is the number of non-zero rows in D. How many non-zero rows are there? There are 3 non-zero rows. Therefore, the rank of A is 3. Thus, the rank of A can be found from the given information. That is about the option 1. Right, option 1 is all right. And in this, we will prove 3 options can be found. And the leftover option is the answer for us. That cannot be found. That is by elimination. We cannot prove that cannot be found. But instead, what we will do, 3 of these options can be found with the given information, and the leftover option cannot be found. So that is the simplest thing for us. Let's go to the option 2. First, note that means determinant of A transpose A, can it be found? That's the question. First note that determinant of A is equal to, its eigenvalues are 0, 2, 4, 6, and we know the determinant of A is the product of the eigenvalues, that is 0 into 2 into 4 into 6, that is equal to 0. Now, determinant of A transpose A is equal to determinant of A transpose multiplied by determinant of A. Determinant of AB is equal to determinant of A into determinant of B. That is equal to determinant of A transpose is equal to determinant of A, because A transpose and A have the same determinant. That will be determinant of A into determinant of A. And the determinant of A square, and that is 0 square, that is 0. So thus the determinant of A transpose A can be found. So the option 2 can be found, option 1 can be found. Let's move to the option 3. Right, that's the question. Now, the eigenvalues of A, and we are talking about the option 3. Eigenvalues of A are 0, 2, 4, 6. And we know the eigenvalues of A plus I are 0 plus 1, 2 plus 1, 4 plus 1, 6 plus 1. It is a standard result. Right. That means the eigenvalues of A are A plus I are 1, 2 plus 1, 3, 4 plus 1, 5, 6 plus 1, 7. Note that none of them is 0. None of them is 0. None of them is 0. Therefore, A plus I will be a non-singular matrix. Why? A matrix A is singular if and only if one of its eigenvalues is 0. So none of them is 0. Therefore, A plus I is non-singular. Therefore, its inverse exists, and eigenvalues of A plus I inverse exists, and the eigenvalues are, if lambda is an eigenvalue of A, the 1 by lambda is an eigenvalue of A inverse. Therefore, the eigenvalues of A plus I inverse are 1 by 1, 1 by 3, 1 by 5, 1 by 7. So thus the eigenvalues of A plus I inverse can be found. Right. That means even the option 3 can also be found. So therefore the leftover one, only one answer is there. Therefore the eigenvalues of A transpose A cannot be found. So that's the easiest thing, rather than proving that A transpose A cannot be found. Anyway, so that's the answer. So the answer to this question is option 4, and that is the detailed discussion of the solution of this problem. Now let's move to the next question, question number 62, with this idea. The given question is, consider the following two statements. Statement A, f of x comma y is equal to x square plus 4xy plus y square has no minimum at the point 0, 0. Statement B, f is not positive definite. Now choose the correct option among the following. Now options are given. A is true, B is false. A is false, B is true. Both A and B are true. Both A and B are false. Anyway, the routine options. And now let's discuss the solution of the problem in detail. We have statement A, statement B. Right. And now look at f of x comma y. So it is a quadratic form. Why? Each term is of degree 2. So it's a quadratic form in the variables x and y of degree 2. And x square plus 4xy plus y square can be written as x transpose ax, where x is the column vector xy. And the matrix A is a symmetric matrix 1, 1. This 4 is to be divided as 2, 2. That's a symmetric matrix. So this means f of x comma y is a quadratic form, and AA is the matrix of the quadratic form f of x comma y. So the characteristic equation of the matrix A of the quadratic form is lambda square, because it is a 2 by 2 matrix, lambda square minus trace of A multiplied by lambda plus determinant of A is equal to 0. That implies lambda square minus trace of A, the sum of the diagonal entries, 1 plus 1, 2 lambda, lambda square minus 2 lambda, plus determinant of A, determinant is AD minus BC, that is 1 minus 4, that is minus 3. So the characteristic equation of A is lambda square minus 2 lambda minus 3 is equal to 0. When you solve for lambda, you will get lambda is lambda minus 3 multiplied by lambda plus 1 is equal to 0. The values of lambda you will get are 3 and minus 1. Now, therefore, f is not positive definite. How do you say? How do you say? Now, a quadratic form is positive definite if and only if the eigenvalues of A are all positive. Here, the eigenvalues of the eigenvalues of A are not all positive. Some of them are positive, some of them are negative. Therefore, it is not positive definite. Therefore, the statement B that f is not positive definite is true. So you have to remember this one. A quadratic form is positive definite if and only if all the eigenvalues of A are positive. Right. Now, further, f of x comma y, that is the quadratic form, is indefinite quadratic form. How do you say? A quadratic form is said to be an indefinite quadratic form if the eigenvalues of A, some of them are positive, some of them are negative, and none of them is 0. Then it is said to be an indefinite quadratic form. Here, lambda is equal to 3 positive, lambda is equal to minus 1 negative, and 0 is not there. Therefore, it's an indefinite quadratic form. When it is an indefinite quadratic form, f of x comma y takes both positive values and negative values are also by definition indefinite quadratic form. So that is f of x comma y takes both positive and negative values. So when it takes both positive and negative values, f of x comma y has no minimum at 0 comma 0. Minimum is not attained for that because it takes both positive and negative values. So this implies f of x comma y has no minimum at 0 comma 0. So the statement A is also true because it has given it has no minimum at 0 comma 0. So the statement A is also true. Thus both the statements A and B are true. Let's look at our options, and this conclusion that both statement A and statement B are true appears against option 3. Therefore, the answer to this question is option 3. That is the detailed discussion of the solution of this problem. And let's now move to the next question. Question number 63. Agreed. The given question is, let U and V be subspace of R power 9 over R, where R is the set of real numbers, and the dimension of U is equal to dimension of V is equal to 6. Then the dimension of U intersection will be at least, we are given 4 options. So you have a vector space R power 9 over R, and you are given U and V are subspaces, and their dimensions are equal and equal to 6, and required to find the dimension of U intersection V will at least be one of these. Agreed. Let's now discuss the solution of this problem. We have the vector space R power 9 over R, right? And the dimension of R power 9 over R is 9. It's a finite dimensional vector space, nine-dimensional vector space, right? And we are given U and V are subspace of R power 9 over R, Agreed. That is, the dimension of U is equal to dimension of V is equal to 7, 6. It is given to us. We recall that U plus V is also a subspace of R power 9 over R, and its dimension of U plus V we have a formula for that. So then U plus V is a subspace of the vector space R power 9 over R, and the dimension of U plus V, we recall the formula, dimension of U plus dimension of V minus dimension of U intersection V, and that is equal to dimension of V is 6 plus dimension of V is 6 minus dimension of U intersection V, that is equal to 12 minus dimension of U intersection V. Agreed. Now what is U plus V? U plus V is a subspace of R power 9 over R. Therefore, the dimension of U plus V is less than or equal to the dimension of R power 9 over R. Agreed. What is dimension of U plus V? 12 minus dimension of U intersection V. This implies 12 minus dimension of U intersection V, we write for dimension of U plus V less than or equal to 9. And this will imply dimension of U intersection V is greater than or equal to 12 minus 9, that is 3. That means the dimension of U intersection V is at least 3. So where is the option? The option is against option 1. Therefore, the answer to this question is option 1. That is the detailed discussion of the solution of this problem. Let's now move to the next question, question number 65, and it is the last question in this discussion. The given question is, let T be a linear operator on R square over R given by T of x comma y is equal to minus y comma x. That means you reverse x comma y and replace the second component of x comma y by minus y. So minus y x. Then the trace of t square is, we are given 4 options. Right. So we have the linear operator t from r square over r to r square over r defined by t of x comma y is equal to minus y comma x. Now let us now talk about t square. T square means you operate t 2 times. Now t square of x comma y is equal to t of x comma y. So t of x comma y by definition minus y comma x. T of minus y comma x will be the second component here is to be, it will come to the first place, first component, changing its sign. So t of minus y comma x is minus x minus y. Right. Now let's write down the matrix corresponding to t square. Right. Consider the standard basis B, that is equal to E1 comma E2, where E1 is 1 comma 0, where E2 is 0 comma 1. So let capital M be the matrix corresponding to t square with respect to the standard basis B. Now let's see t square, its effect, t square of E1 is t square of 1 0 1 0. So t square of 1 0 is minus 1 minus 0. So minus 1 0. So let us write down the matrix M of t square with respect to the basis B is this 1 minus 1 comma 0 is to be written as the first column in the matrix B. Right. T square of E2 is, t square of E2 is 0 comma 1. This is minus 0 minus 1, that is 0 comma minus 1. 0 comma minus 1 is to be written as the second column here, So that will be, the second column is 0 minus 1. So that is your matrix M. So now, thus M is the matrix of T square corresponding to the basis B is minus 1, 0, 0, minus 1. So now trace of T square is equal to trace of M. What is M? Trace of M is equal to minus 1, 0, minus 1. That is, trace of M is sum of the diagonal entries, minus 1 plus minus 1, that is minus 2. Minus 2. Let's look at our options. So this is appearing against option 3. Therefore, the answer to this question is option 3. And that is the detailed discussion of the 4 questions 61, 62, 63 and 65 from the section Linear Algebra that have appeared in TS set, Telangana State set exam in 2023 in October. In that paper, these 4 questions were there with these numbers. And these are the, in this video, I have discussed the solutions of those 4 questions in detail without leaving, any question about them. So I am sure that you have understood the solutions of these 4 questions, and I wish you all the best. Thank you.